Hey guys, welcome to Coronavirus Earth Science. We are on day 1 of our last unit, which is climate. All right. If you look in the content library in OneNote, you'll notice that I have a new folder up. It's climate. You guys can create a new section and add the next 4 days into there, and then we are done. Okay, so today is water cycle, a lot of review, and then a couple new things. All right, only one assignment that's being graded. It is your Castle Learning Climate Post-Test. So please make sure you get it done well, and done on time. All right, here we go. So the water cycle, I know you guys know it, so I'm just going to get right into it. All right, you should know evaporation is how water enters the atmosphere when it goes up, right? Transpiration, some of you may be a little hairy on that, but you did learn it last year. This is when water enters the atmosphere from plants, okay? When plants open up their guard cells, right? And allow for water vapor to evaporate out of plant material. Then when it's up into the atmosphere, it cools, and then it's going to turn back into water, right? So this is condensation, when it turns from gas back to liquid. Evaporation, transpiration, and evaporation again. This is when liquid turns to gas, okay? And then once you have that, it's going to fall down, and that's going to be precipitation. So that can be rain, it can be snow, sleet, hail, any way that the water is coming back down to the surface of Earth from the sky is going to be precipitation. Then it hits the surface, and then it flows downhill, which is runoff. All right, this is everything that we've discussed so far. All right, this is where you should be in terms of your knowledge on the water cycle. The only new stuff that we're going to talk about now is how a lot of that water is going to seep into the ground. And that's called infiltration. And then you have your water table, right? So we're going to get into those terms, okay? But first, let's get through some of the older stuff. So like mentioned before, evaporation is liquid to gas, okay? And this gains heat energy. When it gets warmer, it's going to take that liquid state water and turn it into water vapor. Transpiration, again, liquid to gas, but this is using plant materials. So they open up their guard cells, and then they release water into the atmosphere. Condensation, this is happening in the clouds. This is when we are going back to liquid. All right, so this is gases back to liquid. Then the water droplets form around those dust nuclei that we've spoken about. Then it gets too heavy and then falls. All right, so this is going to be your rain, snow, sleet, hail, water coming down. Okay? Now, here's some new words. So when water is sitting on top of the soil for an extended amount of time, it will start seeping in. All right, water enters the ground. All right, so it seeps into the ground, and that is called infiltration. All right, like in military talk, infiltration, or the infantry, is when they enter something, okay? They infiltrate enemy lines, right? They try to get past it. And if you can, then that means it is permeable, right? If it is impermeable, you cannot pass through. If we were talking about the cell membrane from last year, the cell membrane is semi-permeable, which means that it allows certain things through, right, based on size. So when we talk about infiltration, the soil must be permeable for the water to seep within the soil and into the ground. Then we're going to talk about the zone of aeration, which means that it has pores filled with air. So basically this is what I like to call dry sponge. All right, you have soil that's dry, it has openings, it has pores in it, that's just open, empty space filled with air, so that water will be able to fill that area and will be able to flow through. On the opposite side, you have the zone of saturated. This is wet sponge. This is where the sponge is already filled and saturated with water. And if the sponge is already filled with water, it will not take any more water into it. Okay, so this is the area that they are filled with water, and the groundwater makes the water table. So groundwater is what we call the water that is in the ground. Okay, that's pretty simple. Water in ground. All right, and that's going to make up the water table. That's going to be that boundary between the zone of saturation and the zone of aeration. Okay, and then you have bedrock. This is all the way at the bottom of the soil where you have that solid rock. It is impermeable. Nothing goes through it. Okay, so before I get into the big diagram that's on your note sheet, I just want to quickly show you this picture. Okay, here is a sponge sitting in some dyed water. This boundary is the water table. Okay, this is dry sponge, where it has those empty pores. So this is the zone of aeration. And this is wet sponge. So this is the zone of saturation. Okay, so when we talk about infiltration, we're talking about the ability for water to seep into the ground like that. Okay, and if it rains more and it adds more water, then the water table gets higher. If you're in a drought, the water table gets lower. Okay, so here's the diagram that we have in our notes, in our note sheet. You got to add in these terms. So you can see here's the water table, right? It's that boundary between the zone of aeration on top. So that's the dry soil, and the zone of saturation, which is on the bottom. This is groundwater. Okay, you have your precipitation, condensation, transpiration, which is going up from the plants, evaporation, all that good stuff. All right, now I'm going to just add a couple things. In here, in the dry sponge, all right, so it's also in here, right? This is that dry sponge. In the zone of aeration, when you're close to the base of plants and stuff, you're going to have what we call capillary water. Capillary water is just water that's in the dry soil that's still making its way down. All right? It's not part of the water table. It's not groundwater yet. It's just water that's kind of on its way in transit. Okay? And if you remember the word capillary action is what we call water moving up when we talk about plants' roots and stuff. And then also, this is also known as the root zone, because this is where roots are. Okay? And notice, impermeable rock. This is your bedrock at the bottom. No water's going past that. All right, so infiltration versus runoff. You either get one or the other. All right, so infiltration means that it is seeping into the soil, and this runoff means that it will not seep, right? It will flow downhill. Okay, so these are just a couple factors that will determine if it will seep into the soil or if it will run off, if it will just flow downhill. All right, so take a look. If it's soft soil, nice, spongy, aerated soil, that's going to support infiltration. That's why a lot of people that are doing their gardening, they take a rake and they just mix up that soil, right? They aerate it to get a lot of air into it because it will allow more water to soak in. If it is permeable, all right, the soil must be able to get through. So things that would affect this would be not packed, right? If it's loose soil, right? Loose would be good. If it is not frozen, if the soil is frozen, it's a block of ice. No water will be able to seep through, right? Vegetation, if it has roots, roots always pull water down, and gentle slope. If it's like this, that means water is more likely to pool on top of it, giving it more time to seep, right? You're going to end up with more puddles, okay? If we're talking runoff, packed soil means that it's really packed down. It's going to be harder, like a solid piece. It's going to be more impermeable, so water will not seep in and it'll just flow off the surface of it. No vegetation, no roots pulling it down. Steep slope, right? If it's like this, water's going to hit it and just hit the surface and flow down. You're going to have very little infiltration because the water's just going to flow downhill right away. And then if it's frozen like mentioned before, it is going to be totally ice, right? Like just a cube or sheet of ice. No water is going to be able to get through. All right, so which conditions produce the most surface water runoff? So if it's leading to more runoff, that means that it must also mean less infiltration, right? Because they are opposites. So more runoff would mean that it has to be a steep slope, heavy rain, frozen ground. We're talking number 1 here. Next, in the diagram below is a cross-sectional view of rain falling on a farm field and then moving to the water table. Which word best describes the movement of the rainwater through zone A? So right here, water going down through the soil, that's 3, infiltration. That's a vocab term. Over here, the diagram below represents zones within soil and rock. The zones are determined by the kinds of movement or lack of movement of water occurring within them. What is the deepest zone into which water can be pulled by gravity? Which is the deepest zone that can have water in it? Well, we know this word means water cannot get in it. So that's our boundary. So the deepest zone is the saturated zone. All right, so this is your note sheet. You guys should have been able to get these done. This was our notes and our diagrams. This is what I want you to complete. This. Okay? Hope everyone is well. Hope everyone has a good Memorial Day weekend.